students, welcome to Shruti Academy. So let us start with the third mode of the SCR, which is the reverse blocking mode. In this mode, the SCR is said to be in the off state, and in this mode, the SCR behaves as an open switch. So let us start with the detailed working how the SCR works in this reverse blocking mode. So as the name suggests, reverse. So here we already know the SCR is having three terminals: anode, cathode and the gate. Gate is kept open as we have kept open in the forward blocking mode. Okay. And anode is connected to the negative terminal of the battery and cathode is connected to the positive terminal of the battery. Okay. And so we can clearly see from here the junction J2 is having its p-type semiconductor connected to the negative terminal, and the junction J3 having its n-type semiconductor connected to the positive terminal. So it makes the junction J1 and J3 reverse biased. It makes the junctions J1 and J3 reverse biased. Okay. And J2 is having its n-type semiconductor connected to the negative terminal and p-type semiconductor connected to the positive terminal. So the J2 is forward bias. But alone J2 is being forward biased. It cannot conduct the current. It cannot conduct current because even if the voltage is being provided over here, the junction J1 and J3 are reverse and they will be blocking all the current, and they will be not allowing any current to pass through it. But initially, because of the drift charge carriers, some of the leakage current flows, which is very little and which is of the order of a few milliamperes. So that leakage current over here is said to be reverse leakage current. That leakage current is said to be reverse leakage current. So it will be passing through it initially. Okay, but the J1 and J3 will not allow the heavy inrush current to flow through it because the J1 and J3 are in the reverse bias condition, although the J2 is in forward bias condition. Okay, so if we increase the reverse voltage, what will happen? Initially when we will be increasing the reverse voltage, there will be no effect, and a particular reverse voltage, the breakdown will occur, and then the junction J1 and J3 will be will break, and then the heavy inrush current will be start flowing in the reverse direction. So initially when we are providing the voltage source, the J1 and J3 are blocking the voltage, hence the names come reverse blocking mode. So it is blocking the current to flow through it, J1 and J3, because they are both are being the reverse bias. They are in reverse bias state or the condition. Okay. So let us write down the main point. The main point is that J1 and J3 are reverse biased. Okay, and J2 is forward biased. So this is the main point. So let us try to analyze this working, how it works with the help of VI characteristics. So let us draw the VI characteristics over here. Okay, so this is my forward current, this is my reverse current, I reverse. This is my reverse voltage. And this is my forward voltage. Okay, so initially there is no current, only the leakage current will be flowing, that is due to the leakage current. And as we increase our reverse voltage, from here, as we are going on increasing a reverse voltage, initially the reverse leakage current is flowing, and at a particular voltage which is the breakdown voltage, reverse breakdown voltage, VBR, the junction J1 and J3 breaks and the current starts flowing in the reverse direction. So this is the reverse blocking mode. Which is the off state mode of SCR, which is the off state mode of SCR. So here we can clearly see with the help of VI characteristics that SCR in this mode behaves as a normal diode. Okay, but this mode is not suitable for operating, because in this mode the switching device SCR, silicon control rectifier, gets heated up, and that would eventually lead to the damage of the circuit as well as damage of the device. So heating up is there in this mode. This is the main disadvantage of this mode. So because of the heating up, this mode is not preferred so much. Although it behaves as a normal diode over here in the reversed condition, as a normal diode in reverse, when the diode was working as in the reverse condition, that similar condition is over here in the case of silicon control rectifier. Okay, but not suitable because of the heating. Because of the heating, the device can be damaged. Okay. So this was all about the reversed bias. We can write over here one important point, then, that when reverse voltage is greater than VBR, where VBR is the reverse breakdown voltage. It is the reverse breakdown voltage, or you can also say reverse breakover voltage. Okay. Reverse breakdown or breakover. Junction J1 and J3 breaks. And current starts flowing in reverse direction. Okay, in reverse direction. So we are getting a graph over here. So this was all about the reverse blocking mode. Okay, so later on we will be moving ahead with the latching current and the holding current. So thank you. So please subscribe my channel, please share my videos, and if you have any doubt you can ask me in the comment section. Thank you.